The supply chain knowledge assistant is fully deployed, and its infrastructure is actively running securely in the cloud. To achieve this, we hit three main objectives: provisioning isolated multi-environment infrastructure, enforcing zero-trust secret management, and applying least privilege access. We utilize modular Terraform, Azure Kubernetes Service, and Helm to orchestrate this environment, moving beyond the static configurations found in standard templates. Establishing a secure, automated CI/CD pipeline creates a repeatable framework for scaling supply chain applications and mitigating deployment risks. Step 1 is isolating our environments. We provision two completely separate Azure storage accounts and blob containers to house the dev and staging files. If a corrupted state occurs in dev, physical separation ensures it cannot overwrite your staging infrastructure. Next, we configure our service principal. We assign it strictly to the contributor role on our specific resource group, along with Key Vault administrator. Avoid the common security failure of assigning blanket owner access to your automation identities. With our permissions locked down, we use Terraform to provision an Azure Key Vault and securely store the service principal's client secrets inside it. We then map those stored secrets directly into Azure pipelines by configuring the Azure DevOps variable group resource. This keeps our pipeline from ever handling raw credentials. Pairing physical state isolation with hard code-free secret management ensures that both accidental infrastructure damage and intentional credential theft are effectively neutralized. Now that our security perimeter is defined, we apply our Terraform modules to provision the underlying Azure Kubernetes service clusters. Once the clusters are running, we shift to the application layer. We invoke the Terraform Helm provider to initiate the installation of the supply chain knowledge assistant. You might encounter a major roadblock here. The pipeline can abruptly throw a 401 unauthorized or 404 not found error when it attempts to pull the pre-existing container image. The fix requires explicitly mapping the Azure Container Registry username and password variables directly into your Terraform Helm repository block. Handling container registry authentication natively inside the Terraform provider ensures reliable chart fetching. You bypass the need to rely on brittle manual Docker login scripts. Let's structure our Git branching logic. Feature branches are configured to trigger an initial validation stage, while merges to the main branch trigger your actual deployments. We map this out in our YAML file across three distinct pipeline stages: validate, dev deploy, and stage deploy. We implement conditional logic gates using the succeeded function. This ensures the staging deployment is only permitted to execute if the dev deployment perfectly passes. Shifting to runtime execution, you may hit a second failure point, a pipeline crash citing an invalid value for path.ssh/id.rsa.pub error. This happens because the Azure DevOps agent's default remote working directory does not inherently contain your local SSH keys. To solve this, physically place the SSH key inside the specific dev and staging environment folders, then update the Terraform variable paths to match the Azure agent's exact directory structure. Mastering these YAML conditions and aligning paths with the remote agent's directory creates a robust, hands-free release workflow. Executing kubectl get pods confirms our success. The supply chain knowledge assistant is running perfectly across both the dev and staging clusters. There is one final, frequently overlooked requirement for an enterprise setup: building a parameterized destroy pipeline. Automating the systematic teardown of non-production environments prevents cloud sprawl, keeping your infrastructure clean and saving massive computing costs. Controlling the complete lifecycle, from isolated provisioning to automated teardowns, provides the engineering team with granular control and confidence over the application infrastructure.